Right, so hello, this is the second part of, second question on the June 2014 Edexcel C3 past paper. Obviously it's past paper, it's obvious. So anyway, question 2a, it says find the exact solutions in their simplest form. This is both question 2a and 2b. Now, I was reading the exam report for this question. Obviously it's available to you online, but if you can't be bothered to read that, basically that's probably the reason you're doing this, watching this, because you can't be bothered or you don't understand it. Fair enough, okay. Anyway, so I'll just give you talk about that. So it said in that report that there was a few issues with this question too. People weren't reading the question right. It said find the exact solutions, and people put it in decimal places, which obviously is not exact, and also they didn't know what solutions. Some people just lost, well, so they didn't put, oh, what is a solution? But the first question is 2 ln of 2x plus 1 take 10 equals 0. So, well, wrote that and they just left it there, because they presumably didn't know what the solutions were. Now the only thing we can find a solution for in that equation is x, so that's what we're going to do. Now even if you didn't know anything about, anyway, I'll talk about that first. Now to get x on its own, we'll have to use the inverse of ln, because what that's saying is, that could be saying 2 times sine of 2x plus 1 take 10 equals 0. Because then what you'd do is you'd say, okay, sine 2x plus 1 equals 5, because move the 10 across, divide it by 2, and then you'll have sine of 2x plus 1 equals 5. And then you'd inverse sine both sides, so the inverse sine of sine is just 1. And an inverse sine of 5, you'd work that out, and then that'd be 2x plus 1 equals that, so you'd do 2x equals the sine inverse of 5 over 2, and that'd get you x. But since this is ln and not x, the inverse of ln is not ln to the minus 1. Well, it is, but that gets you the exponential. So that's what we're going to do in this question. So therefore, if you didn't even know that, you didn't know what ln was, you presumably do, just do ln of 2x plus 1 equals 10 over 2, which is obviously 5. Now, what you then do is a similar thing to inversing sine both sides, but the inverse of ln is the exponential. So you'd e to the power x both sides. E to the power of x of ln is just 2x plus 1. And that equals e to the power of 5. Because obviously 10 over 2 is 5, as we mentioned. And then you just simplify this down, so 2x equals e to the 5, take 1. Therefore x is this over 2, e to the 5, take 1, all over 2. And that's in the exact form, can't do anything else with that. Tickety-boo, you've got the full marks for that question. Question 2b, however, a little bit more difficult. Not that much more difficult, but you get 1 mark in that question there for doing the work, and 1 mark for the right answer. This 2b is worth a full 4 marks, so it's obviously going to be a little bit more challenging. The question says, obviously it's the same thing, find the exact solutions to the equation of 3 to the power x times e to the power 4x, equals e to the power 7. Now the first thing that we're going to do here is, because this is 3 to the power x times 4 e to the power of 4x, we're going to divide both sides by e to the power of 4x. That gets us 3x equals e to the 7 over e to the 4x. Now this could be the same as 3 to the power x equals 2 to the power 7 over 2 to the power 4x. What you do is you take away the powers when you divide them in basic indices rule. So therefore 3 to the power x equals e to the power 7 take 4x. Now we could do e to the power of 7 take over e to the 4x, and you just take away the powers. Oops, sorry. Okay. So, what we do then is we ln both sides. And if we ln both sides, that gets us the ln of 3 to the power x equals the ln of e 7 take 4x. And because that's a power, we use our indices log rule. Sorry. So a to the power of x. Yeah, a to the power x equals n. So that's what we use for these two. So therefore, it's x times the ln of 3 equals 7 take 4x times the ln of e, which is obviously 1. So, what can we do with this? Well, obviously you could just do your times and then write it together. On the mark scheme, it says I've missed this out again. No. Yeah, so then what we do is we can write this, we can expand, because that's like sort of a little bracket here, so we can expand that out. So x, I'm just going to write x ln of 3 instead of x times the ln of 3 to make it look a bit neater. 7 times the ln of e, so 7 ln of e, take 4x times the ln of e. And then we can simplify this down by saying, okay, we need our x's over here, so bring the x's onto one side, so we add the 4x times ln of e to both sides, so therefore x, I like this pen, but it runs out, I think, far too easy, probably because it's, no, I think it's probably something to do with it, so therefore x, the ln of 3, and we're adding 4x times ln of e to both sides, and also it cancels it out on the right. That equals 7 ln of e. Now the reason we're doing this, not calculating what ln of e is because it wants it in exact form. So we're having to put it in the ln form, basically, that's what it's saying. So therefore, if we use our basic factorising skills here, so we've got a common factor of e and so yeah, we've got a factor of x, sorry, and let me just get my calculator, make sure I'm not doing absolute crazy here. Ln of e. Yeah, so the ln of e is equal to 1, but we don't write that yet, so we can take out x as a common factor here. So that's x times the ln of e. That is take. Sorry, that's plus 4, because we've got a plus there, because that just becomes 4x. The, ln of e being 1, and that equals 7 ln of e, because we're not changing anything yet, trying to stay low so I can stay out of your way. Therefore, because x times the ln of e plus 4 over 7 ln of e, we can just say, okay, so that's x equals 7 ln of e over ln of e plus 4. Now, that question is a little bit tricky, and I'm just going to go through it again because I had to make a mess of it when I attempted this exam, because it was a little bit tricky. So, just what we did, so we said 3 to the power of x equal times e to the power of 4x equals e to the power of 7. We used the power rule, so we divided both sides by e to the power of 4x. That got us 3x is equal to e to the power of 7 take 4x. ln both sides. Use the log power rule to say the log of a to the power x is equal to ax times the log of a being and x being coefficients of something. So therefore, because ln is the natural log of x, so it's a log, we use that rule. And then we expanded the one on the right out, so the x times the ln of 3 equals 7, take 4x times ln of e, times the right bracket out. So therefore it gets us the x, the ln of e, is equal to 7 ln of e, take 4x ln of e. Then we added 4x the ln of e to both sides because we wanted the x is on one side so we could factorise it. And therefore we could take x out as a common factor. This meant the x times the ln of e plus 4. Now it's not plus 4 ln of e because ln of e is 1. And we could have taken, you could argue that x is times 5, 7 ln of e. But then you might as well say x is 5x equals 7, and then x equals 7 over 5, which I guess you could say, but that's not an exact form, even though it's not a decimal. When it says exact form, it wants it in some kind of ln or e form or sign form or something other than a number, than an integer. So that's why I can see a point if you're arguing about the plus 4. You should say, well, that's plus 4 ln of e. Fair enough. If we'd have taken ln of e out as well, I could understand your point, but we haven't. So you know, I'm not 100% on this mark scheme. I would put 4 ln of e just to be safe, but that's what it says on the mark scheme. So I'm assuming that's right. I'm personally not too happy with it, but you know, that's what it says. So as long as you did something to that effect, you could have done it in a numerous ways. Another method that is accepted by the mark scheme, I'll just talk you through it. My computer will. Oh God, what's it doing? Yeah. So obviously you could write this because we know. Sorry, just without the top bit, if you don't mind. Give me a bit more room. If you didn't know, I'll just explain it to you now. This, when we say the natural log of x, so, sorry, for people who aren't really interested in, I'm just going to explain why we can use log rules for the natural log of x. If you're not interested, because it is a separate tutorial really, I think I've included it, but I just mentioned it in this question if you bothered to watch the videos. But for those people who are just going through the past paper, you can stop the video now and go on to the next question. But for those people who are interested in how we get the natural log of x, how that comes about, then please do continue. So this ln of x business, so we say ln of x for example, what does that mean? How can we use log rules on that? Because to you and I, that just looks like the ln of x, doesn't look like anything else. Why would we say it's the natural log of x? Well, the natural log refers to the exponential being the base. Now, back in C2, we said log of a x in base a was equal to n, or something like that. So therefore, the base was a. And as a is not an exponential, because we didn't know about exponentials back then, that was just a log. And what we generally said, if you remember, we said log, if it has no base, and it's just said the log of 10, for example, then, oh, that's a bad example actually. So if you said the log of 25, we'd assume the base was 10, or a. In this case, because we're talking about the natural log of x, the natural log of x is where we have a base of e. So what we say is the natural log of x, e being the base and x has to be in there, so x is just the number being logged, equals, that could equal n, a, whatever, so that equals n, let's say. This bit is the most important. The natural log of x, this is kind of explained in the first part here. The natural log being the base of e, x. So therefore e to the power n equals x. So that's why we can use the inverse of log. That's why if we would do the inverse of this, we would get the exponential e to the power x, because therefore what we say is e to the power n equals x. So if we did the inverse of that, we'd say e to the power x equals n. So therefore that's how we get around this ln of x, and that's why we can use these log rules. And now that's why it says, if you look in the mark scheme, it will accept this format. We could do exactly the same as we've done here, but we just replace any ln of x with this business. Now the thing that makes doing this way a bit more complicated and not the straight away mark scheme that you would see is when you have ln of 2x plus 1, it becomes a little bit more complicated. Not that much more, but a little bit more complicated. So the base is still e, and where this x is in this one, we replace it with 2x plus 1. Say that's equal to n. So therefore, e to the n is equal to 2x plus 1. So obviously you wouldn't write that in this equation, but that's why it's a little bit more complicated, because you start having additional little bits and bobs here. So this is exactly the same, log e, so this bit here, log e x to the base e, is the same as saying this if we didn't have, so that's the same as saying ln of x. So these two are exactly the same, it's just a different way of writing it. So as I said, that wasn't really relevant to this question, although you could have answered it in that way. And I'm not going to go through it because I use the same method and you can just plug your numbers in or look on the mark scheme, because I can't really say anything more. That was a bit of background information. The rest I'll just be reading off the mark scheme, so there's no point me going through it, because the mark scheme is probably going through it quicker than I would. So anyway, thanks for watching that part of the exam. So that was question 2 of June 2014. That 2B was a little bit of a stinker, and so then we'll be going on to question 3. So see you in a minute.